Hello, welcome to section 3.1. What we're going to do in this section is deal with linear regression, which basically means we're going to find that trend line or a line of best fit that's going to talk about slope, y-intercept. We'll be able to make a prediction, and we can solve for a couple of things. So when we talk about things growing linearly, we're saying that something is going up or down by the same amount every month or year or minute, whatever it is. And that change between your dependent and independent variable is constant. So for this first example, we have a table to the right showing an average gas price for 6 months, and we want to predict the average gas price for August. So notice they're giving us January through June. What we're going to do is go to the graphing calculator on this, and we're going to find what that equation is for the trend line. So the first thing I want to do is establish that January is going to be called my 0 month, February my 1, 2, 3, 4, and then all the way down to 5. And the reason that I'm doing this is when I say January is my first month, what I mean is it's my initial month. It's when I'm starting collecting data. And that's why I'm filling in a value of 0, is whenever our x value is 0, your y value would be your y-intercept. So what we're going to do is go to the calculator on this, and I'm going to enter in all of my data. So I'm going to, shut the ink off here. So what I'm going to do is go to Stat. We're going to go to Edit, and I'm going to enter in 0 through 5. And then what we're going to do is go over to L2, and we're going to enter in all of these gas prices. So $3.15, $3.22, $3.19, $3.28, $3.35, and then another $3.32. Once you have your data in, notice at the very bottom of this, I'm able to go back and forth between these. What that means, if you don't see your cursor like going up or down or anything like that when you're moving your arrows, it means that you have the same number of inputs as the same number of outputs, and that's what you want. It would be really bad news if we ended up with more inputs than outputs with our data, and then when you go back in your calculator, it would give you an error. So what I'm going to do after this to figure out the equation of my trend line is we're going to push Stat. I'm going to go over to Calculate, and then the fourth option is linear regression. And notice it says AX plus B, which is very similar to that slope-intercept form of y equals MX plus B. So instead of using M for slope, they use the letter A. So I'm going to hit Enter above that. Here's my L1 and my L2. We stored our X numbers, our independent variable, we stored into L1. Our dependent variable, which was the gas price, we put into L2. And I'm going to go all the way down to Calculate. And this is going to give me my regression equation. So y equals 0.038. So I'm actually just going to write this down first. So I'll write 0.038 here. And then I'll take a look over at what my B value is, and I'm going to round this up then to 3.16. And we'll kind of talk about what this means, but let me first write it in slope-intercept form. Y equals mx plus b. So it's going to be y equals, you take your m value, which is the a, 0.038, put the x with it, plus my y value, or my b value, which is the y-intercept of 3.16. So again, your trend line is not perfect every time. When you draw a trend line through a bunch of points, like in this case, it's going to kind of go down the middle of them. It might touch some of the points, especially if we graph it on our calculator. But what we're really going to do is just see that trend. And that's, I actually could show you that on this graphic calculator. If I turn my plot on, I can take a look at my data points and notice we're going to have a slight increase of the gas price over time. So I want to see how much it is going up by. And that's going to be the part that's represented by the slope. So the slope is going to tell you your increase in dollars per month. So what that means in this case is we are going up $0.038. So that's almost 0.03 would mean 3 cents. 0.04 would mean 4 cents. So between 3 and 4 cents every month, the gas is increasing. And that's what our slope is going to represent. So again, this is going to represent your average increase in price. And what this 3.16 is going to represent, that's your y-intercept. Notice, if I put 0 in for x, you get your y-intercept. So this is the approximate. It's not the exact. This is the approximate price per gallon for January. Notice our actual price was 3.15, so $3.15. But since the trend line is just a prediction, it's not always going to be exact. Notice when we rounded this, it went up to 3.16. So that means that's just your approximate starting value. So when it crosses the y-axis, if you were to draw in or if you were to graph that trend line on our data or on our scatter plot, it would cross the x-axis at 3.16 because that's our prediction. So if I want to make a prediction for what the gas price is going to be in August, notice that June is what I called my 5th month, July would be my 6th month, and then August would be my 7th month. So what I'm going to do is evaluate this. If I change this to a function, I would be evaluating the function. I'm going to change this to f of x. What I would be evaluating then is f of 7. My 7th month, I want to know what the price is. So I take 0.038 times 7 plus 3.16. And that's what I'm going to do here in a sec. Let me just quickly go back to this. There we are. Okay, my bad. Okay, so what this ends up being then, I'm going to take 0.038 times 7 plus 3.16, and I get an answer. Oops. And I get an answer of 3.426. So I'm going to round that up to 3.43. So what that means is that in August, the gas price will be $3.43. And that's what I'm going to write down below this too. I'm going to say in August, the estimated, or I'll say the approximate price is $3.43, so 3.43. On to the next one. Okay, so here's another example. What I'm going to do for this, I'll open up the calculator again. And what I'm going to do is go to Stat, we're going to go to Edit, and we're going to get another linear regression. So this is saying we're showing monthly record sales of a recording artist over 6 months. Predict the record sales for December. So I'm going to do this the same way. I'm saying January is my initial month. When I say my initial, I'm saying 0. I'm going to go all the way up just like I did before in the last problem. But notice what's happening. When a record hits the shelves, it's really hot. You're selling a bunch of them, and then over time, you're slowly selling less and less. So you can probably imagine our slope is going to be a negative number then because it's going to indicate a drop in sales. So I'm going to put all these values in. 60,000, 54,000, and then all of a sudden it goes up a little bit, which is okay. And then it goes down to 46,000, 43, and 30,000. So now that I have my numbers in, notice same number of inputs as I have outputs. I'm going to want to push Stat, go over to Calculate, and go down to my 4th option, which is linear regression. Hit Enter. I'm going to go down again to where it says Calculate, and this is going to give me that A value and the B value. So my A value, negative 5571, and I'm just going to round these to whole numbers, so I'm going to round down there. And then for the B value, it's 62,429. I'm rounding that one up. So let me write this as a function then. And I'm going to say the record sales are going to be, I'll just write it out as f of x, where f of x represents the total record sales. X is going to be the number of months. And this is going to be negative 55,771x, that was my A value, plus 62,429. So I want to take a second to start talking about what these numbers mean. Again, this represents your slope, which is telling you your approximate change in the number of record sales per month. I think that was off though. Let me go back to this. Did I screw that up? Yeah, that's 5571, not 55,000. Whoops. Okay, so it's 5,571. I screwed that up. 5,571x plus 62,429. That was weird. Okay. So I even made a little mistake there. I went back, fixed it, just threw one number in there. The reason I could see that is because this is supposed to indicate the drop in record sales per month. So I'm going to write that down. This is your average drop in sales per month. So it looks like we're selling 5,500 records less every month. This value would be your approximate number of records sold, or I'll say approximate sales in our first month, which is January. So in that initial month, oops, I should learn how to spell. This is why I don't teach English. In that first month, we are calling January our initial month. We're calling it 0. Notice that the actual sale was 60,000. This is an approximation based off of our trend line. That's what your y-intercept would be. So we're going to predict all the way for December. So if I kept this going, in the last example, we said August was month 7, September would be 8, October would be 9, November would be 10. So we're doing December, which is our 11th. So f of 11 equals negative 5571 times 11 plus 62,429. So I'm taking my value of 11 as an input to my function. I'm going to take negative 5571 times 11, and then I'm going to add 62,429, and I get 1148. So notice that when we started, the record dropped in January, we had 60,000 sales, and now all of a sudden it's almost a year later, and we're down to 1148. So in a complete sentence, I'm going to say, in December, approximately 1148 records will sell. So notice throughout this, because now we're done, throughout this lesson what we really did was we talked about our independent and dependent quantities, we talked about slope, y-intercept, and what a regression equation would look like. We analyzed what the slope would mean in our problem situation and the y-intercept, because that's really important, is talking about what I have in green here, which is what they represent in the context of the problem. And then we use our equation to make a prediction.